Okay, can everyone see my screen? Can someone say something in the chat? Hello? Okay, sweet. So today we're going to be covering stuff on circles. So last week we started doing some circles, and this week we're just going to continue doing circle stuff. So from last week, you guys, this is just revision. So just take a second to read this. So the angle in a semicircle is always 90 degrees, and the angle at the circumference is half the angle at the center. So this is what we covered last week. So here's another theorem. So if you have two angles that are subtended by the same arc, so if you look at this diagram here, angles ABC and angles ADC both share the arc AC. So could you guys try and prove why this is the case? So I'll give you guys a hint. You have to use the second theorem here, so this one. So just take 2 minutes to try and prove this theorem. Wait. So if you guys have any ideas, just put them in the chat, and I'll read them. Yeah. Okay, so does anyone have any ideas on like how to prove this theorem? I'll give you guys 1 more minute. So if you look at the diagram here, I've drawn the radius from A to the center, and then also from C to the center. And if you look back to the previous theorem, which tells us that the angle subtended here is double the angle at ABC. So this would be 120, right? But since ADC also subtends AC, the arc AC, then ADC would be half of this. So this is why ABC is equal to ADC. So I could use any other angle here. It doesn't have to be 60 degrees. It could be 45 here, and then this angle here, APC, would then be 90, right? But then ADC also subtends AC, so it'll be 45 too. So that's why ABC and ADC are equal. So does anyone have any questions? I can't see your screen. Oh, wait, can you guys not see the annotations? But can you guys see the diagram? Like the diagram with the circle? Well, you can't see my screen. Oh, I paused my screen share. Wait, my bad. Oh, I know. Wait, oops. Okay, can you guys see the diagram now? Okay, I'll just go through it again. My bad. So let's say I draw this line here, right? So this is just the radius, right? So this seems to be P. Then since angle ABC subtends this arc AC, then we know that angle APC would be double ABC, right? It would be 120. And that's from the theorem that we learned last week. Right, can you guys see the annotations now? Okay, cool. All right, sweet. Now, if you look at ADC, ADC also subtends AC, right? So we can say that APC is double ADC, right? Because they also share arc AC. So that's why we get ABC is equal to ADC. And it doesn't have to be 60 and 60 here. It could also be 45. So if I have 45 here, then for my ABC, then APC will be 90, right? But then ADC, if we double ADC, we should also get 90. So ADC will be 45. So that's why ABC and ADC are equal. And this only works if they subtend the same arc. So they have to share this AC arc. Or otherwise, this theorem does not hold. Okay, does anyone have any questions? Okay, I'm just gonna move on. Um, oops. Okay, so this is a cyclic quadrilateral. So cyclic quadrilateral is any four-sided shape that has its vertices on a circle. So as you can see here, all of these vertices are touching the circle. And one of the properties of cyclic quadrilaterals is that the opposite angles of a cyclic quadrilateral, so let's say A and then C, if we add them, we always get 180 degrees. And this also holds for DB, D and B. So D plus B also equals 180. So I want you guys to try and prove this um property of the cyclic quadrilateral. So I'll give you guys let's say 4 minutes. So just have a go at proving A plus C equals 180 and B plus D equals 180. Okay, does anyone have any ideas so far? If you have any thoughts and ideas, just drop them in the chat. So Amanat has said that A plus B plus C plus D equals 360. Um, yeah, so that's true, but can you show that A plus C equals 180? We more cut the circle in half through D and B point. Um, yeah, I'll give you guys 2 more minutes and I'll just go through the solution. We'll go over the proof. And also, as a hint, try using the theorem that we used in the previous theorem. So um try using this theorem here to prove the cycle. But can you guys still hear me? I feel like my microphone's broken. Wait, can you guys hear me? Hello? Okay, okay. Okay, cool. So A and C are angles in semicircle 90 plus 90. Wait, let me just go back. Oops. Right, so you're saying that A and C in semicircles 90. Um, so for your so we're saying that A and C are angles in a semicircle. Then if you draw a line through D and B here, would it really give you a half circle? Because let's say I move the points D and B like down a bit more. And if I join the 2 points, will the circle be split equally, right? So you gotta be careful because sometimes the diagram looks like it might be like, like a half of a semicircle, but in other cases it might not. So you're trying to prove like in all cases this theorem holds. Okay, I'll just go through the proof now. All right, so if you look at this diagram here, this makes sense, right? ADB is equal to ACB because so angle Y, um, they're equal because they both subtend arc BD, right? So if I draw the arc that they share, so they both subtend AB, right? So therefore, ADB and ACB are equal. Now, similarly, we can see that DAC, which is this one here, and then DBC, they both subtend DC. So they are equal to. And then I know that A, wait, BAC and BDC are also equal because they subtend BC. So if I just, so using this fact, try and, proceed and try to prove that A plus B, or A plus C equals 180 and C plus D, B plus D equals 180. I'll give you guys 2 more minutes. So does anyone have any ideas at the moment? Just say them in the chat. And this is a judgment-free zone, so it's okay to be wrong if you don't know the answer, or just try to be like more open. Okay, so Josie said that if you do it with all the arcs, you get two triangles with a x and y, and two triangles with two other angles. And the opposite angles have four different angles. Yeah, I think you're on the right track. Yeah, so I'll just go through the proof now. I'll just draw some. Well, there's four angles in the opposite ones. Well, which opposite ones? B and D. Just give me 1 sec. Just double check. Okay, so I've labeled all of these angles with different letters. So I've got Z here, I've got A here, and I know that ABD is equal to ACD. So these are both A, and then BAC and BDC both Z. So like Amarat said earlier, we can add all of these angles, and then we'll find that the sum will be equal to 360, right? So if I add x, wait, this is really hard. Let's have x plus z. So that's my angle DAB, right? Then I add all of these angles. Okay, so does this seem right? I'm just adding all of the angles A, B, C, D, and they're equal. Josie, yeah. Yeah, so Josie's absolutely right. So this is equivalent to what Josie said in the chat. So if we add all of these angles, well, I think I did something. Oh no, yeah. And if I simplify this, I should get a plus x plus y plus z equals 180, right? Now hold up. What is a plus x? Isn't that just angle B, right? A plus x is just my angle B. And then y plus z is just my angle D. So therefore, B plus D will equal 180. And we can do this for angles A and C too. So for A and C, so x plus z gives me A, right? And then plus A plus y. Right, I'm just rearranging this equation here. And this would give me A plus C equals 180. So therefore, we've shown that the opposite angles are supplementary. So good job, Josie, for figuring this on your own. So just moving on. Let me just delete everything. Okay. Um, okay. So moving on. So these are also theorems that we saw last week. So the angle between a radius and a tangent is always 90 degrees. And the alternate segment theorem tells us that the angle between the chord and the tangent is equal to opposite angle inside the triangle. So if you look here, let me just annotate this real quick. You'll see that the blue angle is equal to the blue angle on top here, right? And the green angle, 60 degrees, is equal to the angle here, 60 degrees. So could you guys try and prove this theorem? So this green line here is a tangent, and then all of these vertices of the triangle are touching the circle. So they're all lying on the circle. So just take like I'll give you guys 4 minutes. No, yeah, 3 minutes to try and prove this. And I'll give you guys a hint. If you look here, like draw points here. Maybe if you connect the center to the vertices, this might help you with proving this theorem. So I'll give you guys 3 minutes. Okay, Josie said that because angles on a line sum to 180, the angles in the triangle sum to 180. Um, this is right, but how does this show that this angle here is equal to this angle here? So how does it show that 70, like this angle is 70 and this angle is 70? Because your statement's right, but does it actually show that for any triangle that's, in this configuration, that the angles will be equal? So you want to be more specific and try to show that some equal. Okay, I'll give you guys 1 more minute. Do you guys need more time, or do you want me to start going through the proof? Okay, I'm just gonna go through the proof now. So if you guys look here, I'm just gonna label my triangle with the vertices A, B, and C here. Now let's say I have, so make this point here D. So let's say that angle ABD is equal to alpha, right? No, actually, let me just erase this. Oh, oops. Okay. Okay, it's a really bad diagram, but All right, let's say angle ABP is equal to x. Okay. And then since AP equals PB, so we know that AP equals PB, right? Because it's a circle, right? And they're both equal to the radius, right? So I know that PBA is also x. Now, let's say I draw a line here. That will give me, let's call this point F. Okay. Now, I'm just going to designate this angle APF as angle Y. Okay. So I'm just labeling these with some random variables so far. Okay. So is everyone following so far? Okay. So, wait, someone said something. All right, never mind. All right. So what about this angle ABD? What is this angle equal to? Since this is a tangent, then surely ABD plus PBF equals 90, right? Because PB is perpendicular to the line that's the tangent, right? So I can label ABD with angle Y. All right, does this make sense so far? Okay. Now, if you look at angle APB, what is this equal to? It's equal to 2y, right? APB equal to 2y. Now, what about this point C here? Oh, gosh. Let me just redraw this. All right, what about this point C here? Well, ACB has this arc AB, right? It subtends this arc AB. So therefore, the magnitude of ACB must be half of APB, right? ACB equals APB over 2. Right, that's from the theorem that we learned earlier. So therefore, this is equal to 2y over 2, which equals to y. So I know that ACB is equal to y. Now, since ACB equals ABD, we've shown basically that these angles are equal. And we could do the same thing for BAC and so this angle here and this angle here. So does anyone have any questions so far? Like my bad for drawing a very like messy diagram. So if you have questions, please ask. Okay, no questions? Okay, I'll just move on then. Okay, moving on. So these are pretty common sense theorems. So the tangents to a circle from the same point will be of equal length. So if you look here, DC is equal to CE. And the radius through the midpoint of a chord will bisect the chord at 90 degrees. So bisect just means that it splits the chord into two equal parts. Okay? Does anyone have any questions? All right, no? Let's move on. So this is power of a point theorem. So if you look here, AE times, wait, I'll just take a minute to read this. Okay, basically what this theorem tells us is that if we have, two chords and they intersect at this point E, then the product of AE will be equal to CE, and that DE multiplied by BE will be equal to each other. And this is a different configuration. So the second configuration here, that's saying that BA squared is equal to BC multiplied by CD. And then in this last configuration, the point C is outside of the circle. So if you look at the first configuration, the chords intersect inside the circle, but in this third configuration, they intersect outside the circle. Okay, so we're just gonna do some practice questions. So I don't know, just try to remember these theorems. I'll come back to this later. So the question I want to give you guys is alright, so if you look at the diagram here, I want you guys to find the value of x in the following diagram. So I'll give you guys what, like 2 minutes or 1 minute. It's a really easy question. If you guys have any questions, please ask. Okay, so if you look on my screen here, I've basically just I've written out the relationship between the segments. So try to use this to solve for x. Okay, Josie said that the answer that Josie's saying that x is equal to 2/3. Okay, we'll see if this is true. So AB multiplied by AC equals AD multiplied by AE. Someone said something in chat. Yeah, Sylvia and Raina. Okay, everyone's saying 2/3, so I'll just go over it. So AB is equal to 1, right? And then AC is equal to 4. And then AD is X. And then AE is equal to 6. So solving for X, we get 2/3. Okay. Okay, so this is a very, 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 very basic question. Like you probably won't get this in compositions and stuff. So here's a more challenging question. Also using power of a point theorem. So let's have a go. So this is the question. Just take a minute to I'll give you guys 4 minutes to do this question. Okay, Josie is saying that length AR is equals to 3 and BR equals 12. Um, you could do this, so you could give AR and BR like a random length, but I suggest using a variable because it's not always going to be, because let's say you put 3 here, and then 12 as this length. Then the length of dr and rc could change. So it could be 5 or 6 here. If you like shift it upwards, it'll be like 4 and 7 here. So if you prove, one configuration, then it wouldn't, necessarily hold for other configurations. So that's why it's better to, set them to variables. Okay, so I'm just gonna go over the solution now. Well, not really this full solution. I'll give you guys a hint. Just let me, just one sec. Okay, so let's make length AR x, right? We're gonna give it a random variable. Know that the ratio of AR to BR is 1 to 4. So that means BR must be 4 times the length of AR, right? So BR would be 4x, right? Any questions so far? No, right? Okay, so similarly, we can make this length dr equal to 4y, and then rc equal to 9y, because the ratio of cr to dr is 9 to 4. Oh, wait, I think I've made a mistake. Should be the other way around. So this one should be 9y. This one should be 4y. Okay? Now, it's asking us to find the ratio AB to CD. So we're seeking this ratio here. Now, what's AB? AB is just AR plus IB, right? So that gives me x plus 4x over 4y plus 9y. So that should simplify to 5x over 13y. Okay, so this makes sense, right? Now, what I basically need to find is the ratio x over y. Because once I find this ratio, I can just substitute this into here and multiply it by 5 over 13 to get my ratio AB to CD. So I'm trying to find x, the relationship of x to y. Now, this is where we can use power of a point. So I know that AR multiplied by B equals C times DR, right? This is just power of a point, like we saw earlier. Now, just replace all of these lengths with my variables here. So I'll get 4x squared, then 4y multiplied by 9y. Oh wait, whoops, shouldn't be 4 squared. Just 4x. Okay, does anyone have any questions so far? All right, no questions? Okay. So basically, if I just, do some algebra, I'll get 4x squared multiplied by 36y squared, right? And then find that x over y, simply just this 36 over 4, which is basically equal to 9, which is root 9 equals 3. So that's my ratio x to y. Now, since I found x to y, I mean x over y equal to 3, I can sub this to my original AB over CD ratio that I was trying to find as per the question. So subbing this in, I get, let me just move to the left. 5x over 13y equals 5 over 13 multiplied by 3. So that gives me 15 over 13. And that's my final answer. Does anyone have any questions? Now, if you have any questions, please ask, because I love answering questions. Oh yeah, Raina's got the answer, 15, 13. Yeah. Good job, Raina. So yeah, so that's pretty much the question. If no one has any other questions, I'm going to move on to the next question. Can we prove again A AR times RB equals CR times DR. Um, I think well, the reason why I don't want to cover the proof for this theorem is it will take too much time and we still have a lot of content. So I'm happy to send some, links to a proof of this theorem. Like these three configurations, right? And they all have separate oh, what's the name of this theorem? So it's called power of a points. So just search up power of a point proof, and there should be three proofs for each of the three configurations. So I guess that's your homework. But we really need to move on because we have so much content. Okay. So here's a warm-up question. So this doesn't need power of a point. This is just basic basic trigonometry, well, not trigonometry, but like just basic algebra. I mean, no, basic geometry. So just take, I don't know, like 2 minutes to do this question. So everyone should be able to do this question. So I'll give you guys 2 minutes. Okay, Rain is saying that the radius, oh, wait. Rain is saying that the radius is equal to 2. So let's see if this is true. Oops. Okay, so what can we see from this? If I draw a line here, then I can label this. So this segment here will be equal to 1, right? Because it's simply the radius. And this part here will be r, right? That's my radius. So what I have here is a right angle triangle. So someone said something. Right, never mind. Okay, so using just Pythagorean theorem, right? I'm just gonna redraw this triangle here. This is what I have, right? Yeah, okay. So the reason why this length here is r is because if we look at this line here, this is simply just r shifted here, right? So these lengths are equal. Okay, so it's using Pythagoras. Okay, we get this, right? This is just a squared plus b squared equals c squared. And then we expand this. Get this, right? If I take this and I solve for radius, and I just use, quadratic formula, then I should get two solutions for my radius, right? Now, let's just take a look here. 1 minus root 2 and 1 plus root 2 are my solutions, but can 1 minus root 2 really be the case here? Because what is root 2 equal to? Root 2 is, something like 1.414 or something, right? So it's larger than 1. So this will give me a negative number, right? Negative. So therefore, we have to reject the solution. So thus my solution is 1 plus root 2. Okay? So that's a very easy warm-up question. Does anyone have any questions? Yeah, so when you're doing these questions, you want to be really, really careful. Like you don't want to, straight up assume that radius is 2 because, sometimes the diagram, like from the diagram, it's hard to tell. I'm not saying that 2 plus 2 Okay, so I'm not saying that. Yeah, I'm not. Your solution's fine. So what I'm not did, which is also very clever, so he took this triangle here, and he also used Pythagoras. So it doesn't matter as long as you can use Pythagorean theorem and just get the radius that you want. So Amanat's method also works. Okay, I'm just gonna move on to the next question. Oops. Okay, just have a go at doing this question. Oh, my bad. Wait. All right, this one. I'll give you guys well, my bad. I'll give you guys 4 minutes. And also, guys, just as a hint, try drawing, the radius AC and DB. Okay, do you guys need more time? I'll give you guys 2 more minutes and I'll go through the solution. Okay, guys, so what do we actually have here? So I've drawn the radii AC and DB, and we were told that DB is equal to 8, AC is equal to 3. So what I have here is two similar triangles, right? Because these two angles are equal. And then since it's a right angle triangle, I know that EBD must be equal to CAE, right? So I have two pairs of similar triangles. So this is going to allow me to determine ratios, right? And from ratios, I could get lengths. So eventually I'm trying to find CD. So do you guys want more time? Or all right, Josie's saying that C is 4 because of Pythagoras, right? So CE is equal to 4 because CE equals root, right? Because of Pythagoras. Now, since we have CE, we just have to find the length ED, right? Because if we find ED, we can just find CD because CD equals CE plus ED. And we already know that CE is equal to 4. So we just have to find ED. Okay, I'm just going to go over the solution. So we know that, so we're trying to find DE here, right? Because we already have CE. The ratio of BD to DB must be equal to CE over AC, right? Because these are similar triangles. So ED is my unknown. DB I know, which is equal to 8. CE is equal to 4. AC is equal to 3. So I can basically solve for ED. So ED is going to be equal to 4 over 3 multiplied by 8, which gives me 32 over 3. Yeah, since I have this ED, I can substitute this into my equation here. So I get 4 plus 32 over 3. And that gives me what? 12 plus 32, 44 over 3. So that gives me the whole CD. Okay, so does anyone have any questions? If not, I'll just move on. All right, I'll just move on. So here's another question for you guys to try. And also, if you guys have any doubts, you can always revisit the lectures which are on YouTube. So if you don't understand them now, just you can after the lesson just go to the YouTube oh, I can't even talk. Just go to the YouTube page. Yeah. So here's the next question. So just I'll give you guys 5 minutes to do this question. And also as a hint, try to use similar triangles for this one. So do you guys know which triangles are similar? So we'll just go through this first. So AO1 AO1D looks similar to AO2E, right? So these two triangles appear to be similar. ADO1 similar to AEO2, right? Because they both share the angle FAC and they're also right angle triangles. Someone said something. Yeah, Tracy is right. Now, what about triangle AFC? Because if we look at this angle here, we say that this is alpha, then my angle O2AE, this angle here, for that beta, then since A plus B beta, alpha plus beta equals 90, right? Because it's a right angle triangle, then this angle FCA must also be alpha, right? And since they have the same angles, right, we can say that these two triangles are also similar to AFC. So that's a huge hint. So I'll give you guys some more time to just do this question. So I'll give you guys another hint. So if we look at the two triangles AO1D and AO2E, then the ratio of AO1 to AO2 must be equal to the ratio of AD to the ratio of AE, right? And also the ratio of DO1 to EO1, right? Because they're similar triangles. Josie saying that AO2 to AC, so AO2 to, yeah, Josie's right. If you look at this relationship here, what do we already know? We already know DO1, right? DO1 is just 1 because the radius of the circle was constant. Now, EO1, EO2 be 2, right? So I can basically sub in these numbers here. That would be equal to 1 over 2. Correct. Now, I want to simplify this more because AO1 and AO2, right? How are they related? Well, AO1, which is this part here, and AO2. Seems that AO2 is longer than AO1, right? But they differ by this amount here. And what is this amount? It's just 1 plus 2, right? So we can say that AO1 1/2, right? I'm just subbing in what I know, and I can solve for the length that I want. So it looks a bit messy. I'm just gonna tidy this. So solving this, right, I could just get a 201 equals A01 plus 3. So A01 must be equal to 3. So know that this length here is equal to 3. Now, what is this? It's a right angle triangle, right? So again, I can use Pythagoras. So A01 squared minus D01 squared will give me what? Will give me root 8, right? Josie said something. A to the top of the circle is 2. Which circle are you talking about? Yeah, Josie's right. I'm just going to continue with the solution. So, is it okay if I erase this? Wait, no. I have space on the left. Okay, so I'll just use this. So I know that AD is equal to what? 3 root over 8, right? Now I'm going to consider AD01 and AFC because what am I trying to find? I'm trying to find the area AB, right? So I'm trying to find this length here, so which would hopefully allow me to calculate the area of the triangle using half base, 1/2 multiplied by base multiplied by height. So if we look at triangle AD01 and AFC, what do we know? We know that AD to AF equals D01 over FC, right? Because these two triangles are similar. So I can sub in my lengths here. What's AD? AD is just root 8, right? What's AF? AF is what is AF? Okay, so what Josie said earlier, that the A to the top of the circle is equal to 2. So we can find AF by summing all of these lengths. So the total of AF will be equal to 2 plus 1 plus 1 plus 2 plus 2. So that gives me 8. So AF will be 8. Now, what about DO1? DO1, DO1 is just 1, right? And then FC. So I can find FC. And that should give me, I think, 2 root 2. Yeah. So why am I trying to find FC? Because if I find FC, then I can just use 1/2 BH to find the area of the triangle, right? Because that's what we want here. So I'm just going to erase this half so I have more space. Gosh. Okay, so I've found FC here, right? Now, the area of the triangle will just be 1/2 multiply the base, which is BC, multiply by the height, which is AF, right? And we already know that AF is equal to 8. Then BC is just 2 times FC, right? And we know that FC is our 2 root 2. That should give me 4 root 2. So therefore, area is just 4 root 2 times 8. That should give me 16 root 2. So that will be the area. Yeah, and that's saying that AF is equal to 8, yeah. For C, yeah. So that's how you would get the area, by finding FC first and then AF in using the triangle formula. So does anyone have any questions right now? Any questions? Okay. We have 15 more minutes. So do one more question. And also guys, there's more questions on the handout. So if you guys are confident with these questions, you can always do the questions on the handouts. Okay, this is a really easy question, so I'll give you guys like 4 minutes. So what is this question asking us to find? So it's asking us to find the perimeter, right? So it's asking for this, the length of this thing here. So do you guys remember this, the formula for the circumference? The circle, like it's equal to 2 pi r, right? And here we have semicircles, right? So basically half of the circle. So the length, or the perimeter of semicircle is just pi r, right? Now we have 4 semicircles here. So my total perimeter will just be 4 multiplied by pi r, right? Someone said something. If that's 2 over pi, there's 1 like pi. Okay, so the radius will be what? It'll be half of this, right? So it'll just be 1 over pi. And then substituting this in the formula, I'll get 4 pi multiplied by 1 pi, right? That gives me 4. So yeah, Amanat's got it. And Josie's also got it. Yeah, good job. So this is a, more of a warm-up question, because 1 over pi times pi equals pi over 1 equals 1 times 4. Yeah, that's correct. Okay. Moving on. Here's a more challenging question. Wait, my bad. So let's have a go at this question. I'll give you like, I don't know, like 4 minutes. Okay, guys, does anyone have any ideas? Just drop them in the chat. If you have any ideas? Oh wait, Chris Penn. Chris Penn joined. Oh, hello, Chris. Oh, Ethan's having a family dinner or something, so he just did. So yeah. I'll give you guys 1 more minute and I'll go over the solution. Okay, guys, so what are we actually trying to find here? So we're trying to find the radius of circle 4. So the circle here. So say if I draw a line that passes through the middle. Oh wait, oops. Anyway, I think it's a good first step to find the radius of C3. Yeah. And Josie's saying that the answer is 3/4. So we'll see if it's true. So if I connect this, right? So let the center of C4 be point P, right? And just call this point A, this point B. Then what do we know? We know that AB is 1/2, right? So let's call this point C. So AC will just be half of AB, right? So there'll be 1/4, like 1/4. Mm. Yo, my bad, guys. Okay, so that'll be 1/4. 1/4. Now, what about the length AP? Since this is a circle, right? You know that this longer length here is equal to 1. And I'm just going to give the radius of C4 variable. So let's just call it radius R. Then know that PA be equal to the radius of C1, which is 1, minus the radius of C4, right? And does anyone have any questions so far? No? Okay. Now, what about, so we've found AP, we've found AC. Now, if we find a relationship for PC in terms of R, then we can just use Pythagoras and we can solve for the radius of C4. So let's have a go at finding a relationship, finding an equivalent expression for PC in terms of R. Guys, we only have 4 minutes, so we might just revisit this question next week or something. So I'll give you guys like 1 more minute. All right, guys. We only have like 3 minutes, and we probably can't finish it in 3 minutes. So we'll do this question next week, but try to use the hints that I have dropped. So I'm trying to solve this question as a homework question. So thank you guys for coming. If you guys have any questions, you can always ask by contacting us. And yeah, have a good Matariki holiday, and stay safe with friends and family. And hope you guys have fun. Yeah, thank you guys. Thank you, Chris Penn. Oh wait, Jay's out. Oh wait, isn't Jay's out in the IMO team or something? And also this Yun Chuan kid. Yeah. All right, thank you guys. All right, if you have no more questions, you guys can leave. Okay, Danny, are you proctoring? Hello. All right, I'm just gonna dip in. All right, thank you guys.